Hello, in this video we're going to try and teach this pick and place machine to pass some gas, as it were. Just a little, just a little bit. And why might we want to do that? Well, as you can see, I have the weeny PRU PCB on there, and I've been organizing the bottom camera alignment for that. So to do that, I've been repeatedly getting the machine to pick up parts, put them on, and then look at where they went and check that it's all aligned properly. If it's not, fiddle with the script a little bit until it's okay. And everything's been going all right, and to be honest, I could just put some solder paste on this board now, fill in the rest of these feeders with the appropriate components, and assemble the board. But one thing that's been quite annoying is that when we're dealing with these very small components like this 0603 and the 0805 next to it, they tend to not get released from the nozzle very much, because I've been testing just on the bare PCB. So a lot of the time what you see people doing for this test is they'll put double-sided tape on here so that when the component is placed down, it'll stick down as if there were solder paste, because if there's solder paste, usually the component's going to stick to the solder paste and this won't be a problem. But I'd like to just make extremely sure that the part will be released from the nozzle, regardless of whether there's anything on here that it's going to stick to. And that's just to be sure that it's going to release, and also it's much more convenient for this kind of testing that I've been doing recently. So what we need to do to get that to happen is put a little bit of positive air pressure behind the component on the nozzle as it's released, or as just before the nozzle lifts up, I guess. I haven't really figured out the timing of it. And one way we can do that is I've sort of been preparing for this a little bit. So you can see I have two valves on there. These little dark blue cylinders are solenoid valves, and if we start by looking at the tube that comes from the motor and go up there, we'll see it goes into this T-junction. One side of the T-junction comes down to the bottom of the left-hand solenoid valve, but the other one is just open to the air. So at the moment we don't have any actual positive pressure that's going to push the component off the nozzle. It's just ambient air, which is why it hasn't been releasing very well. So in this video, what I'm going to try and do is figure out a cheap-ass way of providing some positive pressure on that little input there. So for the vacuum side of things, that is the vacuum pressure that we need to suck the part up onto the nozzle, I've been using this little reservoir here, which keeps a steady or reasonably steady level of vacuum within a known minimum and maximum, and that is being regulated by this little pressure sensor there, and somewhere in the software of the script PNP and the weeny and whatever, we have a little vacuum switch over there that's going to replenish the vacuum in here from a larger tank in the next room. It's quite convenient how you can just put these little tubes around and the rest of the system can be completely in a different location. That's quite nice. But anyway, this is for vacuum, right? So that's not going to be helping us with the positive pressure that we need to push the part off the nozzle. So what we'd like to do is have something kind of like that, where we have a steady or somewhat regulated supply of positive air pressure. Not too much. We don't need it to be, blasting things off, because we don't want to disturb any other parts that are already placed with a big blast of air. We just need a gentle, steady, slow, just gentle. We want to be gentle with this, right? So I came up with an idea that's going to cost me almost nothing, and I investigated this a couple of months ago. It seems like it might work, so I'll just show you some video that I took back then. By the way, just before we get into that, I should explain why I didn't want to just use a normal air pump and pressure regulator for this. Apart from the fact that it would cost more, the other problem is that the difference in air pressure that needs to be measured if you're trying to use a regulator or maybe some sort of microcontroller moderated system like I'm using here for the vacuum, the problem is that you can't really measure a very, very tiny air pressure very easily. The reason I can do it with the vacuum is because this is kept at about minus 30 to 35 kilopascals difference from the ambient air around it. So the sensor is quite capable of measuring that fairly accurately. But for the tiny, gentle air pressure that I wanted for the blow-off, it didn't really seem like it would be a very accurate way to do things with this kind of a sensor or any sort of mechanical pressure regulator. I'm just doing a little experiment with an idea that I had for providing a small, constant, positive pressure for a blow-off function. And the way I thought this might be achieved is by using a soft bag not an elastic bag, so I don't want to use a balloon for this. It has to be a bag that doesn't have any like pressure providing means of its own. And it's getting pressure from having a weight sitting on top of it like this. So we have 300 grams of weight sitting on a hard flat plastic board. It's one of those squeegee things for using with epoxy resins and stuff. It doesn't really matter what it is, but it needs to be a constant area and a constant weight. So we're providing a constant force per area down on the bag like that. And you can see it's flopping around like that. And over here in this corner, I just snipped off this corner a little bit and used a little bit of yoo-hoo to just glob some on there, and hopefully it seems to be sealing reasonably well there. At least it's not going down that I can see. And over here we have a T-junction. One side of the T-junction just goes to this bulldog clip, which is going to just used as a open and close valve manually. And then over here I have a pressure sensor, which is connected to an IO mixer. This is just a quick little experiment. I'm not sure if I'll have an IO mixer involved in this eventually or not, but anyway, so I just wanted to see, is the pressure actually constant as this goes up and down? So what I've noticed is that as long as you don't overfill it, and as long as you don't let this piece touch on the bottom, then the pressure is actually reasonably constant. Let me just fill it up slightly more. So you don't want to go past about that point there, and that point is where if you go further, this bag can actually fill up quite a lot more, but if it does, the top of it starts to round over, and then you don't really get the same area of this orange thing touching on the bag anymore. And so we don't want to go any further than this point. Anyway, so in the background, just put this aside for a second. So this is my IO mixer output here, and this node reads the input from the pressure sensor directly, and we're looking at kilopascals here, so it's very, very small value. And because it's such a small value, and this sensor is made for reading about 100 times as much as these kind of numbers, so there's a lot of noise in this value, and it's a bit hard to see what it is exactly, but you can see it's about 0.44 or something like that. So I'm putting that into this slew node, which is just going to slow it down. Not really a moving average, but it sort of gives a similar function. So if we look over here, we'll see it's about 0.44, 0.45, right? And so I'll leave that there, and I'll bring this back. And so I'll just push on this, and you'll see when I push to open the valve, it goes down, and you'll see this going down as well. But when I stop it, when I close the valve again, it will come back to about where we are at the moment. So open, whoops, see the bag going down, the value is about 0.28. But then when I close it, we come back to, well, the first little part we drop a lot. So we've dropped from 0.44 to 0.41, 0.42 maybe sometimes. But from this point on, we don't drop quite so much. So I'll hold it here so I don't drop it off the side. But if we go open, 0.27 to 8, close, and we're back to 0.40, so slightly down again. So it's not a perfect constant pressure, but it's pretty close, and one thing it is for sure is very, very cheap. So I think I might expand on this a little bit more. I'm actually wondering if maybe this plastic bag itself, like, it's not very big. I was thinking I'd need something about 3 or 4 times this size, but it might be okay, just this little bag. And obviously I don't want to be pumping it up with my breath though, because as you can see, it's already gotten quite foggy in here from the humidity going into it. But yeah, so I'll let it get, okay, so open. You see, as it's draining out, the pressure is fairly constant as well. Oh, so the other thing I should do is use some double-sided tape to stick this thing to the bag, probably, because we don't want to have that toppling over. And it's a bit tricky to guide it. You need something that's going to let it go perfectly straight up and down, ideally. Or maybe like a lever from the side, like this would be okay. I'm not sure. But anyway, so we're all the way, we're probably about 1 centimeter away from the desk here. but we still have 0.4 when the valve is closed. And we go all the way down. I'll just stop. Oh, it's going to tip over again. Yeah, maybe this bag's not quite ideal. Okay, it hasn't quite... Oh. I can... There we go. Okay, so it's still riding on the airbag. And we're at 0.39 now for the pressure there. So it's changed from 0.44 to 0.39 throughout the full range of motion that we're going to be using. So it's fairly constant, and I think it's good enough. But each time, see, we're back to 0.44. It seems to be quite repeatable. So it's not perfectly constant, but it is easy to do, and it's repeatable, so that's nice. So as you can see, that experiment was fairly promising, and this is the weights I was using in the bag. This is just a bag from the bargain bins, or whatever you call it at Pack and Save, the bulk bins. And so in the meantime, that was a couple of months ago, so I bought some more of this tube, and I bought this nice little 12-volt pump. It's nice and quiet. It's a little bit weak and a little bit slow, but that's okay, because we don't really need it to be fast or strong. And the 12 volts is easily switched from the weeny. And I also discovered that I needed to have a valve here, because unfortunately this pump, when it's not running, the air can leak back through it that way. But fortunately I found these little cheap valves on AliExpress. I think they're like $1, and they fit into this tube very nicely, and the pump is just strong enough to push through that in the forwards direction. So mainly the issue at that point was this bag, as you saw, it wasn't really that suitable. And I was wondering what I could do instead of that. And then I remembered that when I was a kid, oh, excuse me. And then I remembered that when I was a kid, I had this, oh, God, what was I? What was I eating yesterday? Jesus. And then I remembered that when I was a kid, I had one of these things, which you may have seen. It says on there, poo, poo. When anyone sits down, it emits a real Bronx cheer. And so I thought, well, I'll get one of these and see what it's like. And it does have a tiny bit of elasticity to it, but only when it gets pumped up quite a bit. If it's not pumped up much, it's exactly what I want. It's just sort of a loose, airtight bag with a decent area that doesn't have any one particular way that it's going to tip much. And it's it's basically just perfect for what I'm going to use it for, hopefully. I haven't really used it yet. As you can see, I haven't glued that in there, but the next step is to glue this in. I have already constructed a little seesaw kind of a thing with some switches that will detect when it's gone too far down or too far up. So let me show you that. Okay, here's how we're going to do this. I made a little mount or a clamp or whatever on my laser cutter, and I have a couple of simple switches. I actually bought these switches to make my first CNC machine ages ago, and they've been sitting around for years, so they finally have something to do. Just a kind of a switch like that, right? And we have a lever with some weight on it. Let me just take that off. And so the bottom switch is going to switch when it gets to about there. So that's as low as it can go there. And then at the top it's going to switch there. So it's about a 5 centimeter range on the head of this screw. And the head of the screw is going to go into that little divot on the little piece of dowel on top of this piece of plywood. And we put that in the middle of the whoopee cushion, obviously. And I think I might use these weights here. They are hoverboard motor clamps. Quite often these are aluminium, but sometimes they're polymer plastic, but sometimes they're also steel. So I have some steel ones. And these are about 80 grams each, so that makes this 160 grams, which seems to be, it's probably going to be okay like that. I have another one, can put some more weight on, and I think it's just going to sit there nicely, but if it doesn't, I can just zip tie that around there, I suppose. And we have a zip tie on here. This is not a proper seal, but I'm just, demonstrating how it works. And then we've got the pump over here. If the pump is sitting on the desk directly, it kind of rattles and vibrates and moves around. So I've found that these pieces of foam from like a floor mat, they already have round holes in them that are pretty much the right size. So if you just put a couple of those around there, it's much quieter. and it doesn't move around. And then over here we just have a LiPo with about 11 volts on it. So if I turn this LiPo on like that, you can hear it start to pump. It's a bit slow, so I might have to fast forward this. Actually, it's kind of slow. So that's the bottom switch releasing, and I'll just manually turn this off when I hear the top one click. Okay, so you can see that's about where it's going to go up to at the top position. So I think this is going to work quite nicely, and it's super cheap. The only slight downside is that for the base of this platform here, you either need to weigh it down a lot, or you need to do what I'm going to do, which is just screw it into the bench like that to make sure it doesn't move anywhere. It's just a little bit of a downside, but that's okay. I'll just do that. So if I take the valve off here now, we'll be able to see it go down. And we should hear it click when it gets to the position where the pump would turn on. Like that. Alright, I have everything wired up and the base is screwed down to the desk. And I'm going to use the I/O mixer to control the logic, because it's not really doing much else. It's only controlling the lights, like the LED rings. I could also use the weeny PRU, the script PNP overrides to control this. I'll show you how you can do each of those after this. But anyway, we can see when I click this down, it turns on, and when I click it up, it turns off. So it requires a little bit more logic than just simple dumb switches, which is why I was talking about using the I/O mixer for it. But what I realized is that I can just take these off if I want to disable this separately from all those other ones. So I might want to have this not running, but use all the other vacuum valves that I have and keep those running. So anyway, this would be a convenient way to do it. So instead of strapping these weights on, I think I'll just leave them sitting here like that. So hopefully now this will turn off by itself. There we go. Looks great. So here's the configuration that's running on the I/O mixer. This stuff on the left is for the LED lights, which we're not worried about right now. We're just looking at this stuff on the right. And we have two inputs. They are digital inputs. And I have those set to be pulled up because the other side of the switch is ground. So we have a signal and a ground pin going to each of those. And to make it a little bit easier to understand, I've immediately inverted those so that the value is going to be positive. These are like a 1 or a 0 value, right? Digital inputs. So the value is going to be 1 or positive when the lever is in one of these positions. So when the lever gets to the bottom, this is going to be true. And when the lever gets to the top, this is going to be true. And then over on the output side, we have a digital output, which just turns the motor off or on, and that's on pin 3. And we need to keep track of a little bit of state. It's not quite as simple as just switching when something happens. We have to keep track of what are we doing right now. Is it on? Should it be running or should it not be running? So for that we use this store node, and this just stores a value, and we're only allowed to change that value when this input here is true. And that's going to be true when either the lever is all the way down or it's all the way up. And then we can change it to whatever is coming in through this source value, and that is going to be lever down. So basically when we're at the bottom, we can change it to positive if this is down, but then when it gets to the top, we'll also be able to change it because this one will become true, right? But when we change it at the top, we're going to be changing it to 0 because the lever down will not be true. I hope this makes sense. Anyway, so that's how that's working. Another way I could have done this is by using these overrides in the script PNP, but I didn't really want to do this because I don't have so many pins on the weeny PRU, but on the I/O mixer I have tons of pins. And also these are running at a 1000 Hertz update rate, and what we're doing here with the switching this pump on and off is it doesn't really need to be so fast. But what I could have done if I was willing to use the weeny PRU for this is I could set up an override or two overrides that are like this. So for example, when digital output, well actually it would be when digital input 1 is high, set digital output 3 to high, for example.
And the other one would be when digital output 2 is high, set digital output 3 to low. So there'd be two rules here that sort of counteract each other, and that would work just as well.
Alright, so everything seems to be working alright. Just to finish off with, I'll show you how it can work, just to confirm that it's doing what it should. So I was running a little test here, and I came across a situation where basically my bottom camera was not plugged in, my second USB camera. So it stopped in the middle saying, uh-oh, there's no camera. And the vacuum has been released, but there is a part still on the nozzle. Hopefully you can see at the top of the screen. It's a little bit hard to see, unfortunately. But the 0805 resistor in this case is still on the nozzle. So I'm not exactly sure whether it's because of a little bit of residual vacuum, or maybe a little bit of magnetism in the nozzle tip, or even a little bit of electrostatic attraction or something like that. But whatever the reason, now I can run just a 1 second opening of the valve that has the positive pressure behind it, like this, and hopefully you can see that the resistor was pushed off the nozzle, just like we wanted. Okay, I think I'll leave it there for this video. It looks like this idea is going to work out okay. I still have a few things to figure out. For example, how much weight do we want on here, and how long the nozzle needs to be open, the valve needs to be open for the pushing. Obviously 1 second is too long. I tried with 1/10 of a second just now. It seems to work just as well, so that's nice. And this zip tie seems like it's going to be okay. I was planning to put some whoopee or something inside there to seal it really well, but the zip tie is doing okay. It's not really leaking out more than once in about every 5 minutes or so, which is tolerable. And if I just leave it with the zip tie only, that lets me quite easily take the tube out and maybe change it for something else in the future if I want to. Would have been a nice time to clean up this horrible rat's nest of wires, wouldn't it? But I did not do that. Anyway, so thanks for watching. Bye bye.